This is how a 216 Chevy engine dip system works according to me. I took air pressure and I traced out all the ports to see exactly where they went and when they were pressurized and what was not the dip system when it was not pressurized. So the way that this system works that I can see is oil pressure comes from here, comes straight up into the port here. There's a fairly large port, and so with this valve here installed, with the distributor valve installed, okay, and with it closed, okay, partially closed, then you have pressure in there all the time. All the time you have pressure. It goes to your crankshaft, then your camshaft, and then it goes to your rocker arms. All the time to the rocker arms from that port. That port also feeds this port. This port, which is a, I think it was like a 3/32 hole, comes out and goes into this port, which goes down to your oil pan. And there's a little tube here, the tube that fits right here, and it fits down into this tube. No gasket, it just fits straight into it. And so that feeds all your ports for your connecting rods and the troughs. So now we have at idle, let's say at idle, 3 to 5 pounds at idle. You have pressure going to all your necessary systems, your crank, your cam, and your connecting rods. So now when you come up out of idle, okay, and the pressure increases, okay, the pressure will cause this distributor valve to open, all right? So now you're going to bleed pressure off here. It's going to go over to here to this port again, okay? More flow, maybe not pressure because it's just dumping into open space, no resistance. So it's a lot of flow coming into here, this port, which goes down to your oil pan. And so that's how your oil pan gets lubed at higher RPM. This port here is the port that goes up to your cab. That's what you read on your cab oil pressure. This port here, if you're hooking up a oil filter, that is the inlet. This here would be the return line going into here. So it would go into here, okay? If you put a spin-on oil filter on, you should have a 1/16 restrictor in the supply line, I think it's the supply line, going to here, okay? So that way you will have maintain oil pressure at idle. That is the reason they have that 1/16 restrictor in there, is to make sure you have that pressure, at least 3 pounds, going to your crankshaft and rocker arms and camshaft. That is very important. Now I've ran the engine and I have gotten some pressure readings and stuff. I'm going to run it. I'm going to run it again and let you see the pressures when it's cold start and when it's warm and all heated up. And then you can make your own determination about the oil system on this thing and whether you need to put a oil filter on. I will also give you some figures about the how much flow that I think goes through the oil filter and at what pressure at the end of these video. These gauges that I have hooked on the truck, this here is a 0 to 10 pound. That's on the left side. And this one is a 0 to 15 pound on the right side, the one going to your cab. This is my 53 Chevy pickup, 53 engine, original engine. I've hooked a gauge up to check the oil pressure to see how this system works, as in my last video. This here is hooked up, this one here is hooked up to your, the same gauge port that goes to your cab, and that pressure is your crankshaft pressure, and then the crankshaft goes to your camshaft, and there's also a port in there. The same pressure will go to your rocker arms all the time. So whatever pressure you have on this gauge is going to your rocker arms. This one here is hooked up to the port that goes to your connecting rods. And I explained how that worked in the last video. So this one here would be the pressure that would go to the inlet of your oil filter. And this one here is the pressure that this pressure would have to override in order to go through the oil filter. And you do need a 1/16 inch restrictor to maintain your oil pressure at idle. Okay, I'm going to do a cold start here, and then we'll see what it looks like. And then I'll do a warm once it warmed up. Okay, this was a cold start. This is a cold, engine cold, and it's 1,000 RPM, 1030 weight oil. Okay, this is going to be about 2,000 RPM, and the engine's still fairly cold. So here we go. Okay, engine's warmed up, and it looks like at idle it's sitting there between 5 and 6 pounds on the right gauge, which is your cabin, and on the left gauge it's 0 pounds. And so then I'm going to run this up to about 3,000, and then you can see what it is. Okay, this one will be at about 170 coolant temperature, and the engine is warm, and we'll run it up to 2,000 at first, and then I will take it on up to 3,000, and then you can watch the gauges. was 3,000. Now this is just going to be kind of odds and end at the end of this thing. 1030 weight is what I had in the thing. The book says you're supposed to run 20 weight oil until unless it's 90 degrees and above consistently the ambient temperature. The engine has 2,000 miles on it, 2,100. It's got inserts in the crankshaft and in the connecting rods. It's not babbited rodded. It's been modified. That's before I got it in '75. So the pressures that I only showed you a couple of the runs that I had, so you can kind of get an idea about the stuff. Let me see. At the book says that at 2,000 RPM, you are supposed to have 14 psi on this gauge here, which is going to your cab. And I was not even really close to that. It was down lower. And this pressure here, when the oil was really hot, this thing here would only go up a pound, if that, sometimes, if the oil was really hot. And let's see, you need to remember to have your 1/16 hole in there, and this is the one that I made. The brass looking one, just barely see it, and that's in the supply line. Is where I have mine. On your canister type oil filters, they have it in the return line. It's in about 1.25 inches down from the stem that sticks up through your canister there. The figures I got for how much oil flow you're gonna get, it was just, I just did it at 14 psi and 4 psi, which was about right. So very loose figures, because it depends on if you have a chamfer on your restrictor, or if it's a straight edged. There's other factors that go into this, but you're probably going to get at the 14 psi around, and these are loose figures, plus or minus 30 to 50%, 0.08 to 0.15 gallons per minute, and at 4 psi somewhere around 0.05 to 0.09. And your 14 psi one, you got to remember, if you have pressure in this gauge, it has to offset that, so you'll get even less than what I figured. As far as this gauge goes and the low pressure going to your rods, you have to remember you have to have restriction in order to build up pressure. So that means the fluid, the oil, is flowing and coming out of each of those rod tubes at a high flow rate, so that when you run it up to 3,000 RPM or a little bit below that, it's really streaming out of there, and those rods will catch that oil as they come around. So this is, you're not to worry about this too much, and you always have a flow unless your distributor valve opens through that one port I said, which was about 3/32 seconds. So you always have some flow there to go into your rods. And you have the troughs there, which should be full of oil, and that should take care of your rods. And I've not had any troubles since 1975, and it was 20-some years old then.